So we're going to start and then we're going to delta S, then delta energy. So this is just kind of the introduction to energy stuff in physics if you've taken AP Physics. So this should be some review, maybe some new stuff. Obviously, usually change in volume at work in terms of gases. When we're talking about work, in order for work to sort of change in volume. Heat. So heat is the energy used to cause the temperature. Remember that it's a transfer of energy, and we always transfer the energy of motion. Our equation for that is 1/2 c squared. That should be mostly a review. Also let me talk about our systems versus our surroundings. So we study the system, okay? The system is the occurring. The surroundings are going to be everything else. So let's say you're reacting water. The reaction is surrounder. So we have three types of systems. We have an open system where matter and energy can be exchanged with the surroundings. Closed system. So systems exchange energy, however, they cannot exchange matter with the surroundings. So there's only an energy transfer. So that's what thermodynamics and thermochem is focused on. 3 is an isolated system where neither energy nor matter can be exchanged with the surroundings. Thermodynamics states that energy is conserved. So that's what we're dealing with here. We want a So we talk about the internal energy, which is capital energies of a system. This is usually referred to as delta. Pretty difficult to quantify from mental energy to the initial energy. So that's how we kind of calculate where the enthalpy calculations come from. So I just want you to have kind of a background information about it. Really, the other thermodynamic quantities we're going to study. So the sign is important because a positive value is going to mean that the system gained energy from the surroundings, and then it moves around in terms of and then gives free energy. The positive and negative signs are going to have a little bit of a different meaning, but for now we're going to be talking about energy and enthalpy. The negative value is releasing energy, defined as Q plus W. So Q is our heat added to a system or lost from a system. W is the work done on the system from the surroundings, or work done on the surroundings from the system. Again, on the AP test, no one's really going to ask you to calculate W, where this information is coming from. For Q, remember, is defined as heat. So if Q is positive, heat flowing into the system. If it is negative, that means heat is flowing out of the system. W is work. If work is positive, this means the surroundings do work on the system. If it's negative, this means the system does work on delta overall energy change. So if it's positive, that means it's going to be endothermic. So there's going to be energy flowing. If it's negative, that's going to be exothermic. That means the total energy is flowing out of the system. So let's look at some problems here. Gases A arrangement to form a solid. As the reaction occurs, the system loses 1150 joules of heat to the surroundings as the gas reacts to form a solid. As the volume of the gas decreases under constant pressure of the atmosphere, the surroundings do 480 joules of work on the system. What is the change in internal energy? All right, so our delta E equals Q plus W. So Q, the system loses 1150 joules. So if it's losing heat, that's going to be a negative Q. And then it says do 480 joules of work on the system. So if the surroundings are on the system, work. So that's plus 480. So our value here is going to be negative D joules. So we're just going to add those values up. So the next video is going to kind of go more into this volume. What does that mean? So if the volume is decreasing, that means that they're decreasing. So that's going to be the surroundings doing work on the system. That's positive work. If the volume increases, that means the system is pushing out on the surroundings. That's going to be a negative value for work. The video will kind of go a little bit more into that. In which cases does the internal energy decrease or increase? All right, so heat is absorbed. As heat is absorbed, the delta E is going to be an increase. It's going to be positive. A change in which Q is 30, work is 44. Well, if I add two positive numbers together, it's going to be an increase. A process in which the system does work on the surroundings with no change in Q. 0, so Q equals 0. And then it says the system does work on the surroundings. The definition of that is going to be negative. So I'm going to have 0 plus some and a decrease in the delta E. And then a process in which work is done on the system and an equal amount of heat is withdrawn. So if work is done on the system, that's positive. And then an equal amount is withdrawn, that's going to be negative. If they're equal, that's going to be 0. There's going to be no change in the delta E of that system. All right, some more calculations here. And remember, this is just background information. No one's going to ask you to calculate the delta E of a reaction or a system. It is cooled by removing 0.655 kilojoules of heat. It shrinks on cooling, and the atmosphere does 382 joules of work on the balloon. So just be careful. These don't match. I'm going to change this to joules. This is 655 joules. So I removed heat, so that means my Q is negative because I'm removing. and then the balloon is shrinking. So that means I'm doing work on the balloon. If the surroundings do work on the system, that's going to be about equals Q plus W. So that's going to be negative 655 plus 382, which gives me an ending value of negative 273 joules. A 100-gram bar of gold is heated from 25 to 50, during which it absorbs 322 joules of heat, because that means there's no work, the change of volume work. It's absorbing 322 joules, so our Q is going to be positive. There's no work done on the system, so the work is 0. So therefore, our delta is equal to the Q value, 322 joules. So E for each of the following cases. So these are pretty easy. We're just doing Q plus W, so we're just adding these two values. So for letter A, we get negative 25 kilojoules. Letter B, again, negative 421 kilojoules, 155 kilojoules. And then in which of these cases does the system do work on the surroundings? So remember, that means we're looking for a negative value. All of the work values are negative. So all of these conventions of QW, remember, if heat is flowing into the system, that's a positive value. If it's flowing out, it's a negative value. Do work, it's going to decrease. That's if the system does work on the surroundings, that's going to be a negative work value. So that volume is going to increase. And then overall, delta E, if it's positive, that's going to be endothermic, because the flow, and then it's delta E, going to be transfer of energy out of the system. So very important in chemistry, we look at things from the perspective of the system. In other sciences, they might look from the surroundings. So just in the future, you always want to know, are we taking this from the point of view of the system or the surroundings? And in chem, we're going to always go from the system.